Welcome back. Today we're going to talk about logarithmic functions and their graphs. A couple of things that we need to understand going forward is these graphs that we're going to look at, logarithmic functions, are the inverses of exponential functions. And so I'm going to sketch you a couple things here. First one is this. If I've got an exponential function here, and obviously we remember that it goes through 0b here. But this is y equals b to the x. This is what we've studied before. And this is if b is greater than 1. Our logarithmic function, this is the line y equals x. Our logarithmic function is going to be related to this one this way. It's a mirror image. So this is going to be log base b of x. So this is y equals, or f of x equals log base b of x. It's the mirror image as it's reflected across here. And so these are going to be inverse operations. These are going to undo one another. So that's important to remember. The same thing is true for our other exponential function we looked at, our decay here. And this is y equals b to the x if 0 is less than b is less than 1. Well, again, our line y equals x goes this way, and our inverse function is going to go something like this. So y equals log base b to the x, and again, that's the inverse of those that are reflected across y equals x. So, how do we change between these forms? When we change between these forms, they are very, very, very related. For a good reason. They are inverses. And so they are very related. And a couple of the background of this is if x is greater than 0, and 0 is less than b, but b is not equal to 1, we're going to have an equation that looks like this. Y equals log base b of x. This is true if and only if b to the y power is equal to x. So notice, what we've got here is a situation where the base is the base. So the way that I like to think about it is if I have a log base b of x is equal to y, I could go around the horn. So x equals b to the y power. So this b kind of bumps y up, and y is our exponent, but b is the base of the log, and b is the base of our equation here. Knowing that, when we evaluate these, it says, what is the log base 2 of 8? Now, some of your calculators are going to allow you to put in log base 2 of 8. But we can do this without a whole lot of headache, because what I'm going to say is I don't know what it equals, so it equals x. Well, if I don't know what it equals, evaluate means find the answer, then I can just bump it up. So 2 to the x equals 8. Well, 8 is equal to 2 to the third, so 2 to something equals 2 to the third, so x is equal to 3. That's all we have to do for this. Write it in terms of our exponential form and bring it around the horn. So if I don't know what this equals, it's x. So 3 to the x equals square root 3. Well, 3 to the x equals 3 to the 1/2. So x is equal to 1/2. Okay? Why don't you go ahead and pause here. See if you can do these next three. They're very quick hitting. So see if you can do these next three. When you come back, I'll explain each of the next three to you. Okay, we're back. On this one, again, setting it equal to x. 5 to the x is equal to 1/25. Well, that would be 5 squared on the bottom. So that would be equal to 5 to the negative 2. So 5 to the x is equal to 5 to the negative 2. So x is equal to negative 2. Okay? 4 on the bottom. So 4 is our base. So if we've got log base 4 of 1 equals x, 4 to the x equals 1. What power do I raise something to get 1? It would be 0. So x is equal to 0. X, so 7 to the x equals 7. So x is equal to 1 in that one. That's the basics of it. these basic properties of logarithms feed from that, or they follow logically from that, or they explain some of the other pieces that could be the other cases. If I've got log base b of 1, it's equal to 0, because b to the 0, if I bring it around the horn, b to the 0 is 1. Well, the same thing is true for natural log. That's log base e. The natural log of b, the natural log of 1 is equal to 0, because e to the 0 equals 1, because this is natural log is base e. Second thing that could happen, log base b of b, and it's equal to 1, because b to the first, if I bring it around the horn, b to the first is equal to b. The natural log of e is equal to 1, because if I bring it around the horn, e to the first is equal to e. Next one, log base b of b to the y power is equal to y, because b, if I bring it around the horn, because b to the y equals b to the y. Okay, because it simplifies to the correct answer, to a true statement. The natural log of e to the y power is equal to y. For the same reason, e to the y is equal to e to the y. The last one is b raised to the log base b of x is equal to x, because log base b of the x is equal to log base b of x. B and log base b cancel out, so I'm left with x. These would cancel out. I'd be left with just my x. So b to the log base b, because raising b to a power and log base b undo one another. So the same thing can be said for e. E to the natural log of x is equal to x, because the natural log of x is equal to the natural log of x. E to the natural log of x. These cancel out. B to the log base b of x. These cancel out. Raising it to a power and logging it to the same base, so the base b and the log base b cancel out. They undo one another. So knowing what we know, evaluating base 10 logarithms, and these are evaluating some natural logarithms, it's the same kind of thing we did up above, but we're just looking at it from maybe a new perspective. Log is base 10. So if this equals x, 10 to the x is equal to 100. Log is base 10. So this is 10 to the x equals 10 squared, which is 100. So x is equal to 2. See if you could do these next 5 on your own, and when you come back, I'll roll through them and we will show you exactly how to do them. So go ahead and pause here and try them. Okay, we're back. That was a short pause because, you know, as we get into this, a lot of it's review from Algebra 2. Maybe even some Algebra 1, depending on your exposure to it. So as we do this, these are the basic rules of logarithms. This would be set it equal to x. So 10 to the x is equal to the 5th root of 10. Well, 5th root is the 1/5 power. So 10 to the x is equal to 10 to the 1/5. So x is equal to 1/5. So the answer is just 1/5. 10 to the x. 10 to the x is equal to 1 over 1,000. 10 to the x equals 10 to the -3rd. So my answer is x equals -3, or to evaluate would be -3. This one's a little bit tricky, but if you remember these properties up here, I had my b to the same raised to the log of the same base. These cancel out. This is just 11. Same thing here. E to the natural log. These cancel out. This is my answer. For this one, I've got, this is base e to the x is equal to e to the fifth. So x equals 5, or to simplify, just 5. The properties of exponents. Bring it around the horn. Set up an equivalent expression, and then what you can do is you can fill in that blank to solve for that exponent. All right, transformations. We're transforming these functions. It is very much the same as what we've done. I've got a graph here for you to look at. And what I've got here is I've graphed, so I need, pull this down a little bit. I'm comparing the function to the graph of the original. If f of x is log of -3 minus x, my original would be what? Well, it would be f of x is equal to log of x. Let's just hypothesize. What do I think has happened inside the function? Okay, so let me simplify this a little bit. I've got a negative and a negative. So I can take out a negative. Log of -3 plus x. Log of negative x plus 3. What does it seem to look like? Remember, log is a function. It's like x squared. And so it looks like what has happened is I've got a negative inside, so I expect it to be reflected over y, because it's inside the function, not in the front. And plus 3 means left 3. So let's see what we've got. If I go to my graph, I've got my red here, which is my original, log of x, and I'm expecting this to be flipped over y and left 3. Here we go. This goes over x, or sorry, over y, and it would be at, so if this is 1 right here, 1, 0, that would mean it would be at -1, 0, and if it goes 3 to the left, that would mean it ends up at -4. Okay, so it flips and it moves 3 to the left as per our prediction. So I can draw this in, looks something like this. Our original goes this way. Check out a sketch, goes like that. Goes this way. And our new one is over here at -4, and it goes this way. Okay, that's the basic gist of it. Check out this one, see if you can do this one on your own. We'll talk about it in class. But I've got a negative not only inside the function, but also outside the function, and I've got this -1 that is not inside the parentheses. So think about what that would do as far as translating our graph. And thanks for watching, guys. We'll see you next time.